To begin, we need to create a project. Next, we need to import metahumans. I am using Quixel Bridge to do this. Import 3 metahumans so we can set up a multi-NPC dialogue. Drag 1 metahuman into the scene. Enable all missing plugins and project settings. Before restarting the editor, go to Edit Plugins. Make sure that the Enhanced Input and Common UI plugins are enabled. Restart the editor and accept to save all changes. When the editor restarts, go to Edit Project Settings. Make sure that Enable Enhanced Input Support is checked. Search for Render Focus Rule and set it to Never. Go back to the plugin settings, search for Dialogue and Quest Master, and enable it. Then restart the editor. When the editor restarts, make sure that the Show Engine Content and Show Plugins Content options are enabled. Go back to the project settings, search for Controller, and add the controller input data for your platform. Open your project's input mapping context file and add a mapping for IA Toggle Quest Journal UI. Here is an example of the mappings I've done. You can, of course, change the inputs as needed. Find your game mode configuration and open it. From here, there are 2 possible scenarios. If you don't have a custom player controller class in your project, you can use the one provided by the plugin. If you already have a custom player controller class in your project, you will need to follow additional steps to integrate Dialogue and Quest Master with your existing one. Open your custom player controller class and switch to the full Blueprint editor. Then add a BPC Dialogue Master component. Now, go to the Class Settings Details panel and add an implemented interface. Search for BPI Dialogue Master interface and select it. Go ahead and implement the Get Dialogue Master component method. Implement it to match this blueprint code. Open the BP Dialogue Master Player Controller Blueprint, located in the Plugins Content folder, inside the Blueprint folder. Copy all the selected nodes from the event graph. Paste them into your custom player controller class event graph. Connect the node coming from the Begin Play event at the end of your class Begin Play event. Create any missing variables. Only Dialogue Master UI should be missing, by right-clicking on the missing variable nodes and selecting Create Variable. Implement the Get Dialogue Master UI method. Your custom player controller class is now correctly integrated with Dialogue and Quest Master. Navigate to the Engine, Dialogue and Quest Master content folder and drag and drop the BP Dialogue Player actor into the level. For this tutorial, we will use metahumans, but you can adapt the process to any existing character. The next step is to replace the default UE5 mannequin with a metahuman. Make a copy of the metahuman blueprint you want to use as a playable character and name it BP Playable Metahuman. Open BP Playable Metahuman, go to Class Settings, and change the parent class from Actor to BP Third-Person Character. Select the Mesh component. Change it to SKM Manny. Set the Anim class to ABP Manny. Drag and drop the root component into the Mesh component. Reset the root location and rotation. Select Use Livery Target Mode and set it to True. Select the Mesh component, search for the visible variable and set it to False. Search for the visibility-based anim tick option parameter and set it to Always Tick Pose and Refresh Bones. Go to the event graph. Right-click on the Begin Play event and select Add Call to Parent Function. To switch from BP Third-Person Character to BP Playable Metahuman, open BP Third-Person Game Mode. Set the default pawn class to BP Playable Metahuman. If your metahuman is not animated when you play the game, follow these steps. Reopen the BP Playable Metahuman blueprint. Select the body component. Set its anim class to the matching retargeting animation blueprint for your specific metahuman. It should now work correctly. Now, we will apply the same process to create metahuman dialogue actors. The only difference is that instead of setting the parent class to BP Third-Person Character, we will use BP Dialogue Character instead. Duplicate the original MetaHuman blueprint and name the duplicated one with the actor suffix. Open it and go to Class Settings and change the parent class from actor to BP dialog character. Go to the viewport and drag and drop the root component onto the mesh component. Reset the root location and rotation. Select Use Livery Target Mode and set it to True. Select the mesh component. Set its visible parameter to false. Set visibility-based anim tick option to always tick pose and refresh bones. Repeat the same process for each MetaHuman actor. Delete the previously placed MetaHuman from the level and place your new MetaHuman dialogue actors in the scene. Now let's set up the specific features for Dialogue and Quest Master. To identify the speaking actor during a dialogue and target the camera on it, Dialogue and Quest Master uses tags. These tags should be unique. If you have the same NPC in multiple locations on your map, this is not a problem. The tag doesn't have to match the NPC's name, as the name can be specified independently. Additionally, the system uses the body tag to identify the body for playing body animations, and the head tag to identify the face for playing facial animations. Now let's name our characters. I have chosen the following names for mine. The male NPC will be named Adrian Vega. The female NPC will be named Jade Sloan. The player will be named Vince Rivas. First, let's add Adrian Vega as a tag for the male NPC. Next, let's add Jade Sloan as a tag for the female NPC. Finally, let's add Vince Rivas as a tag for the player. For the player, we will add this tag directly in the BP Playable MetaHuman blueprint. Now, let's check that the body and head tags are correctly assigned to all of our actors. Here are the general rules with the body tag. The body tag should be assigned to the master pose component, if you have a modular character, or directly to the mesh component for a simple character. It must always be applied to the component that controls the character's animation, the component that owns the anim BP. Here you can see that the body tag is already assigned to the mesh component. That's because it is already set up in the BP dialog character base class. The anim BP must include a default slot to play anim montages. Next, for the head tag, simply assign it to the face component. Very important remark. To ensure good lip sync quality, you must set the visibility-based anim tick option parameter to at least only tick montages when not rendered on your character's face skeletal mesh. If not set, the montage will only start when the face becomes visible on screen, which might not happen if you use a level sequence to focus on something else and then return to the character's face. Apply the tags to each of your actors. For the player, let's edit BP Playable MetaHuman. We will apply the head tag to the face component. For the body tag, we will apply it directly to the mesh component of the parent class. This way, all child classes will automatically have the tag correctly applied. Now that our characters are ready to participate in a dialogue, let's create a dialogue. To create a dialogue, right-click in the content drawer, then go to Dialogue Master, Dialogue Asset. The Dialogue and Quest Master Dialogue Graph Editor appears. In this editor, you can configure the actors participating in the dialogue as well as the player. Let's assign the actor names and set a default camera shot for them in the Dialogue Asset properties. Here, I use the full name for both the actor identifier and the unique identifier override. I also disable localization on the unique identifier override. The actor identifier appears in dialogue subtitles and can be translated. The unique identifier override is used to find the actor to focus the camera on in the level. This identifier must be unique and must not be translated, or it could cause issues when locating the correct actor. For NPCs, I recommend using the default shot front left actor camera, and for the player, front right player camera. Of course, you're free to choose the camera that best fits your scene. To start making our characters speak, drag from the Start node. A context menu will appear, allowing you to create dialogue lines for the different participants. You'll also see a branching node option, which we will explain later. Here, I'm adding the dialogue lines I generated using ChatGPT. ChatGPT or other LLMs can assist you in the dialogue writing process. You can change the color assigned to each actor for better readability in the dialogue graph. Let's speed up the process. Once you've finished creating your dialogue lines, you need to associate the dialogue with the character that triggers it. To do this, select one of the NPCs and add the BPC dialogue actor component to it. Next, you can select the dialogue we just created in the dialogue asset field. As you can see, the camera for the player isn't working correctly, and the cameras for the NPCs could use some adjustments. First, let's adjust the camera positions. To do this, in the dialogue asset, you can use the camera additive offset field. This acts as an additive fix to the camera's position. Here we'll slightly lower it because the models used are a bit smaller than the default UE5 mannequin. Additionally, we'll add the default shot for Jade, which I had forgotten earlier. This correctly fixes the camera position for the NPCs, but for the player it's still not right. This brings us to an important interface, Dialogue Actor Interface, which is already implemented by the BP Dialogue Character class, which is why it works for the NPCs. However, we haven't implemented it for the player yet. So let's go ahead and do that. Go to the class settings of the BP third-person character class and add the Dialogue Actor Interface. Now, we need to implement the Get Dialogue Actor Ground Root Transform function. To do this, we will position an arrow component on the character to indicate the position of their feet on the ground, as well as the forward direction. This will help place the camera correctly. Place the arrow component correctly at the character's feet, ensuring it points in the forward direction of the character. This will help the system determine the correct position and orientation for the camera. Now, implement Get Dialogue Actor Ground Root Transform like this. As you can see, everything is looking great. Now, let's generate voice audio using a text-to-speech tool. Here I'm using ElevenLabs, which offers a free plan to get started. Other tools are available, and you can also record audio and facial animations using LiveLink or other capture tools. In this tutorial, I'm demonstrating an alternative approach using a TTS system combined with Unreal Engine 5.5's MetaHuman performance, which can generate facial animations from voice audio. Here, I'm taking each character's dialogue lines and generating the corresponding audio. Each character will have their own assigned voice.
We've already got what we need, Rivas. The question is, do you have what it takes to convince us?
Our distrust is very expensive. You ask a lot of questions for a guy who wants a deal.
Let's speed up the rest of the process. Once you've generated the audio files for the entire conversation, rename them for easy identification. I usually include the voice name, the character's name, and a snippet of the dialogue in the file name. Create a folder and import the files into your project. Now we'll generate the facial animations linked to the voice audio. First, enable the MetaHuman plugin. Go to Edit Plugins, search for MetaHuman and enable it. Then restart the editor. Once the editor has restarted, select all the voice audio files, right-click, and choose MetaHuman Performance, Process and Export to Anim Sequences. Create a folder to store the facial animations. Set the prefixes and suffixes as desired, then click Export. Here, you can enable or disable Generate Blinks. If enabled, the character will blink. Then click Create, and Unreal Engine will generate all the animations. As you can see, the facial animations have been generated. Once that's done, save everything. Then, select all the animations, right-click and choose Create Anim Montage. Now, let's go back to the dialogue asset and assign each audio file and facial animation to the corresponding dialogue line. Select the dialogue line. In the Replique section, assign the voice sound and the face lip sync anim montage. Do this for each dialogue line. Once that's done, save the dialogue asset and test the dialogue.
I thought there were supposed to be more people.
We trimmed the list. Too many eyes, too many risks.
You ask a lot of questions for a guy who wants a deal.
And you two seem a little too relaxed for people who have something I want.
We've already got what we need, Rivas. The question is, do you have what it takes to convince us?
We've never seen you work with our kind before. What makes you think we can trust you?
You can't, and I can't trust you either. But if we're here, it means we need each other.
That's an honest answer. Now let's see if you're as reliable as you are clever.
It looks pretty good, but we can still improve it by enabling the camera blend. To do this, go back to the dialogue asset and adjust the dialogue camera blend time to a value between 1 and 3 seconds.
I thought there was supposed
As you
to
can
be
see,
more people.
now the camera
We trimmed the
transitions
list.
smoothly
You asked
between the
them.
gameplay camera and the
We've
cinematic
never
camera.
You can't.
By pressing the
honest.
skip key, you can skip through the dialogue lines. Now, let's refine the dialogue and add conditions to make NPCs react more naturally, for example, recognizing if they've already seen the player. First, we'll give the player the option to accept or decline the mission. To do this, we add an empty node so the camera stays on the player during the choice. Then we add the 2 possible responses. The short spoken text is used for displaying choices in the interface. If it's not set, the spoken text is used by default. Now, let's add the NPC's reactions to the player's different responses. When the player chooses to accept the mission, we'll add an action to the last dialogue node to start a quest. Now we need to create a quest to assign it to this action. Go to the content drawer, right-click, select Dialogue Master Quest Asset, name it and save it. We'll edit the quest later. Let's first finish editing the dialogue. Go back to the last node of the dialogue where the player accepts the mission and select the quest we just created in the Start Quest action. Go to the beginning of the dialogue, select the first node, and enable the Playable Only Once option. This ensures that a branch can only be played once. Combined with the branching node, this option allows for dynamic dialogues where NPCs don't always repeat the same lines. The branching node works as follows. It checks the conditions of each dialogue node connected to it, starting from the top. The first node with a valid condition is selected. For those with programming experience, it functions like an if-else statement. Now let's add more branches to our dialogue tree. There's a branch where the quest has started, but the player hasn't delivered the required item yet. The NPCs will remind the player that they won't give anything until they get what they want. There's another branch where the player brings the requested item to the NPCs. Here, we add a condition to this branch to check if the quest is at a specific progress stage. For this branch, we verify if the quest is at the Got the Packet stage. We'll use this identifier when creating the quest to mark the step where the player has retrieved the packet. On the other branch, we will check if the quest is at the Search the Packet stage. Let's complete the dialogue branch where the player brings back the expected item. Now, let's add a branch for the case where the player has refused the mission and returns to see the NPCs, who will ask if the player has changed their mind. To do this, we will rename the user ID of the node where the player declines the mission. This way we can check if this line of dialogue was chosen by the player. To test if the player has refused the mission or not, we add another branching node here. The NPCs will ask the player if they changed their mind in case the player previously refused the mission. To do this, we use the has dialogue line played condition, and we'll reference the user ID set earlier on the dialogue line where the mission was declined. If we follow this branch and the condition is met, we will offer the player the choice to accept or decline the mission again. To do this, we connect to the nodes we previously created to give the player that option. Here, I use a branching node as a reroute node to keep the dialogue graph clean. Let's save the dialogue and test it soon. But before that, let's create the quest. Reopen the quest we created earlier. This graph is similar to the dialogue graph, with a start node and an initial step node automatically created by the editor. A quest always begins at an initial step. In our case, we will identify this first step with the ID referenced in the dialogue, Search the Packet, because at the start of the quest, the player has not yet brought the packet requested by the NPCs. By dragging from the output pin of this node, the editor will prompt you to create a task list to proceed to the next step. Here we will use the task, Go to a Location. With Go to Location tasks, it's possible to enable a waypoint if desired. Here, we use the Description Override field to customize the displayed task description. If this field is left empty, the description is generated by the task's getDescription function. By dragging from the output pin of a task list, the editor allows us to create a new step. This way, when the player completes all non-optional tasks in the task list, the quest will advance to the next step. Here we will use the ID got the packet that we referenced in the dialogue and assign it to the quest step. This way the dialogue condition will be met when the quest reaches this step. Now we'll add a new task where the player must return the packet to the NPCs to complete the quest and progress in the story. To do this, we use the Play a Dialogue node task. Next, we go back to the dialogue and assign an ID to the final node of the conversation where the player hands over the packet. We'll use this ID to ensure the quest detects when this dialogue line has been played, allowing the quest to conclude. To mark the quest as completed, we add a final quest succeeded step after the last task list in the quest. There are still a few adjustments to make, completing some description override fields, giving the quest a name, and adding a general description as well as descriptions for each quest step. First, I'll replace the Go to Location task with a Go to Actor Location task. This task is more dynamic and allows us to track a moving actor. Here we'll use one of the default cubes in the level. After that, we'll test the dialogue and the quest, making final tweaks as needed. Here I'm assigning a unique tag to the cube the player needs to reach. Then I specify this tag in the Go to Actor Location task, along with the actor class. In this case we're using Static Mesh Actor, but the more specific the class, meaning fewer instances in the level, the better the performance. So, in your games, try to use classes with fewer instances to maintain optimal performance. Let's test it. First, I play the dialogue and refuse the mission. Then I come back and we can see that the NPCs say something different. They offer the mission again. This time I accept. We can see that the quest has started at the end of the dialogue. You can also view it in the quest journal by pressing the key you've assigned to open it. We can see that the quest name and descriptions are missing. If I go back to speak to the NPCs right away, they react to the fact that I haven't done what they asked me yet. If we turn around, we can see a waypoint guiding us to the destination. You are free to activate this or not, depending on the level of help you want to provide the player. As we approach the objective, the task gets validated and we move on to the next step of the quest. Finally, when we go back to speak to the NPCs to finish the quest, we see that they have a new dialogue and the quest is successfully completed. Now let's refine the dialogue and the quest. First, we'll add a condition to the dialogue line where the NPCs offer the mission again to check that the quest hasn't already started. Next, we'll add a name and a description to the quest. Then, for each quest step, we'll assign a name and an optional description. If no description is provided, only the objectives will be displayed in the quest journal. Let's test it again. We refuse the mission. We come back and the NPCs offer the mission again. This time we accept the mission. The quest starts correctly, and this time we can see its name in the quest tracking interface. In the quest journal, the display looks better with the quest name and detailed descriptions. As we can see, the descriptions update according to the quest's progress. When we return with the requested item, the NPCs conclude the quest. Once a quest is completed, it moves to the Finished Quests section in the quest journal. And finally, if we come back to talk to the NPCs after the quest, the correct dialogue lines are played.